Today I'm going to look at adding and subtracting fractions with unlike denominators or not like denominators, because this is going to look a little bit different than the form of when we have the same denominators in our fraction. So what we mean by unlike denominators is if we have a problem like this, a over b plus c over d, where the denominators are not the same. They're not the same value. So something like 1/2 plus 2/3, just think of something general, that's not the same denominator. So we can't just do 1 plus 2 across the top and then do something. We can't do that. Not able to do that in that scenario. So when we have unlike denominators, what we're looking for here is called the LCD, or least common denominator. Meaning we want to make the denominators the same, but make it the smallest value as possible. So let's put this to numbers rather than just talking about abstracts here. So like the first problem I have, 1/2 plus 2/3. Denominators are not the same. So we want to make them the same. So as you're starting this process, if you're new to working with fractions, it might be beneficial for you to write out the multiples of each number. And what I mean by that is like the multiples of 2. So 2 is 2, 4, 6, 8, 10, and so on. And 3 is 3, 6, 9, 12, 15, and so on. So what you notice here, what we're looking for is the least, the smallest value that they both have in common. What do they both have in common that's the same? That's 6. Whoops, terrible. That's 6 right here. So the smallest value that they both go into is 6. So that means my least common denominator is going to be 6. And as you get practice with this, you don't have to go through this whole process of writing out all the multiples and trying to identify. You'll just start to develop like a rhythm to it and notice some patterns when you're looking at fractions with denominators, and notice some quick tricks to it. You know, there's a method where, well, if I just multiply the two denominators together, then I'll get a factor. And that's fine, you could do that, but just sometimes that makes it more work than needed. And I think I have an example to illustrate that, yeah. So let's make our denominators both 6. So our least common denominator is 6, meaning I want to make both denominators 6. I am going to multiply this 2 by 3 to make that 6. Whatever I do to the bottom of a fraction, I do to the top. What do I have to multiply 3 by to make it 6? I got to multiply by 2. Whatever I do to the bottom, I do to the top. So our new fractions are going to be 3 over 6 plus 4 over 6. Now notice my denominators are now the same. So what we do when denominators are the same is we add across the top. So I'm going to do 3 plus 4 and keep the denominator at 6. So 3 plus 4 over 6. 3 plus 4 is 7 over 6. And know what you're trying to accomplish here. If your teacher is preferring the fractions written one way, or you're submitting your homework through a textbook, like whatever, make sure you know the directions. Some might require mixed fractions, some are fine with improper. Typically, improper is just fine. Like once you get into the little bit higher level, like algebra, calculus, and so on, like we leave them improper. You don't have to convert it to mixed. So that would be 7 over 6. Does not simplify, so leave it as is. Okay, let's look at number 2. So our denominators of 5 and 4 are not the same, so we need to make them the same. I'll show you the multiples idea one more time with this. So 5 is 5, 10, 15, 20, 25, and then 4 is 4, 8, 12, 16, 20, 24. And hopefully at this point you noticed, like, ooh, 20 and 20 is the smallest number. So we got to go a little bit big, but that's okay. Not anything crazy. Just 20 is the smallest number there. So that means I want to make both denominators 20. Okay, this common denominator is 20. So I want to make both denominators 20. So how do I do that? I have to multiply 5 by 4. Whatever I do to the bottom, I do to the top. And remember, when we're doing this whole idea of whatever we do to the bottom to the top, we do to the top, is we're modifying the visual of the fraction, and multiplying by that number on top is not changing the value, it's just changing the visual appearance. So what I end up with is 12 over 20. But remember, 12 over 20, 4 goes into 12 3 times. 4 goes into 20 5 times. So it simplifies back down to 3 over 5. but that doesn't help us add. So we're changing the visual of it. We're not changing really the value of it. So that's why we want to offset that by doing the same thing to the top of the fraction. And then we're going to do over here. Let me move this over. I keep moving the whole thing. All right. I don't want to make this too confusing. I'm going to erase this then. And then we have to multiply this one by 5 and multiply that by 5. 4 times 5 is 20. So we're going to have 12 over 20, like I had before, plus 5 times 2 is 10 over 5 times 4 is 20. Same denominators, 20. That was the whole goal. Now we are able to add. So I'm going to do 12 plus 10 over 20. 12 plus 10 is 22 over 20. Now don't just circle it and move on. Make sure you know, can it be simplified? And the answer in this case is yes, it can be simplified because 2 goes into 22, 2 goes into 20, so we can simplify by 2. So what I'm going to do is I'm going to divide both the top and bottom by 2. 22 divided by 2 is 11. 20 divided by 2 is 10, so I get 11 over 10. I don't want to make this whole video about simplifying fractions, so if that last step there confused you, check out the simplifying fractions video. I don't want to make this a whole extended video on simplifying fractions and adding and subtracting with unlike denominators. Like just know we simplify here. This is a simplification right here. Let's look at the next one, number 3. So in this one, I have the denominators of 3 and 10. So this is where I'm going to stop writing them all out because I'm going to be writing quite a bit if I had to do the 3s, because 3, 6, 9, all the way through 30. So hopefully you know it's 30, because 10 is 10, 20, 30. So sometimes it's a good idea to just look at like a bigger number, like 10. Like, you know 3 doesn't go into 10, and 10 doesn't really have a whole lot of help with 3, so we have to go all the way to 30. So that means this one's going to be multiplied by 10. This one's going to be multiplied by 3. And this is a good one with that idea of multiplying just the denominators, like saying like, oh, it's 3 times 10, it's 30. Like, okay, make the denominator 30. That's fine. I'm not saying anything wrong with that, but sometimes that just makes it a little bit bigger than it needs to be. So let's get back on track here. We're going to do 2 times 10 is 20 over 30. Plus 3 times 7 is 21 over 30. 20 plus 21 is 41 over 30. And that's not going to simplify. That's a little messy. So I'm going to leave it as is. Okay, number 4. A lot of people get a little thrown off with problems like this. When you see a problem like 1 plus 2/3. This isn't as complicated as it looks. Just think of 1 as this. 1 is 1 over 1. So if I have 1 over 1 plus 2/3, my least common denominator is going to be 3. Because 1 times anything is going to get that term back. So I just have to make it 3. So all I have to do is just multiply this by 3, multiply this by 3. So really I have 3 over 3 plus 2/3. And there's a quick trick to that where you see like 1 plus 2/3, you just make it 3 over 3 like that. Like if this was 2/5, 5 over 5, 2/7, 7 over 7, and so on. So I'm just kind of showing you the extended version of that explanation, but it's really a quick little turnaround. So then you're just doing 3 plus 2 is 5 over 3. So the denominators, keep the denominator the same. And there it is, 5 over 3. Can't simplify that at all. So these next two I have, these are examples of why it's not always the best to just multiply your denominators together. Because you don't always need to. Like if I look at this, and that's going to be, if I took that method of just multiplying the denominators, 5 times 10 is 50, I'd have to make this 50. So I'd have to multiply this by 10, multiply this by 5, and that's going to make the numerators a little bit bigger. But we don't need to, because here's why. Check this out. 5 and 10. Does 5 go into 10? Yes. So let's make the least common denominator 10. Make the denominators 10. So all you have to do then is multiply this by 2, multiply that by 2. So then we have 8 over 10. And I don't even need to modify 1 over 10 at all. It's done. It's already 10 because 5 goes into 10. So since I have just 8 over 10 minus 1 over 10, same denominator, Subtract across the top. 8 minus 1 is 7 over 10. There it is. Same thing with number 6. Like, don't make your life more complicated than it needs to be. 3 goes into 9. So since 3 goes into 9 already, just multiply this by 3, because we want to make that 9. So I'm going to have 5 over 9 minus 3 over 9. Denominators of 9. 5 minus 3 is 2 over 9. So I like those problems because a lot of people do like to just focus on the, oh, I'm going to multiply the denominators at all time, and then that's going to be my least common denominator. It's not always the best strategy if you're not really careful. It's not going to be wrong or anything, but just why make it more complicated? Okay, last two I have in this video. Here we're just looking at 3 fractions. So how do we approach this? So for 3 fractions, there's 2 ways of doing this. First way is breaking it up like this. Looking at this fraction, these 2 fractions, getting the least common denominator, simplifying, doing all that fun stuff, and then once you get that answer, you subtract off 2 over 11, and then you have like a new problem. Like, that's fine. I don't know which way is easier or harder. I'm sorry, I didn't finish my thought. So one way is doing this, boom, boom. And the other way is just trying to find the least common denominator amongst the whole problem. So you're trying to find the least common denominator between 2, 22, and 11. Now, in some cases, that's easy. That's not super complicated. But what if we had like 4 or 5 or 6 fractions, or even just like really weird numbers, where finding least common denominator might make it a little bit more difficult? So I typically, in a scenario like this isn't super hard to just look at 2, 22, and 11 and notice 2 goes into 22, 11 goes into 22, because 11 times 2. So my least common denominator is going to be 22. Like, that's not super tough to notice. And even if you're like, I'm going to just start with this, what you would notice then is, wait, 2 goes into 22 11 times. So then you would notice, like, okay, well, let's multiply by 11. What do I have over here? 11. I'm going to multiply that by 2 then to make that all 22. So that's just a way you could just think through it more than anything. So we have 11 over 22 plus 17 over 22. And I'm going to tack on that minus 4 over 22 because I noticed that my least common denominator was 22 here. I had to multiply this by 11, and I already had 11 over here. So I had to multiply that by 2 then to make that 22. You could piece that together. All right, so let's go ahead and now add and subtract across the top. So we just move left to right, adding and subtracting. So 11 plus 17 is going to be 28 over 22 minus 4 over 22. And don't simplify yet. You got to keep working. So we're going to do 28 over 22 minus 4 over 22. 28 minus 4 is 24 over 22. Now simplify. Now that we've finished adding and subtracting, we are now going to simplify. So let's see, what's the best way to simplify this? Let's just do by 2. 2 goes into 24 12 times. 2 goes into 22 11 times. 12 over 11 will be simplified. So that one's not too bad. I know it looks a little intimidating with that 22 there, but once you start to just think about the values, like, okay, 2 goes into 22, 11 goes into 22, done. Where number 8, it's not that easy. So number 8, we have 4, 6, and 2. So here's how we want to think about this. Like, just take a second, look at all 3 numbers, see if there's an easy, quick way, like how we did with 22 here. 11 goes into 22, 2 goes into 22. Does that happen here? 6 does not go into 4, 4 does not go into 6, 2 goes into 6, 2 goes into 4. But like I said, though, 4 and 6 are causing some issues here. So that's not just a quick, easy fix. We got to think a little bit more. So then you just start going through some factors, like, so 4 goes into 8, 6 does not go into 8, 4 goes into 12, 6 goes into 12, 2 goes into 12, boom, I found it, least common denominator of 12. So since it's 12, we're going to have to modify each value a little bit differently. So this needs to be multiplied by 3, this first fraction. What do I have to do to this one? This one needs to be multiplied by 2, because 2 times 6. And then the last one needs to be multiplied by 6. It's 2 times 6. So we are going to have 9 over 12 plus 2 over 12 minus 6 over 12. And then now we add or subtract across the top. So same denominators all around. 9 plus 2 is 11 over 12 minus 6 over 12. 11 minus 6 is 5 over 12. So there it is. So adding and subtracting with different denominators, this is a skill that you're probably just going to need to practice a little bit as you get used to this. It's difficult at first, just find that least common denominator, and it's really easy to shoot right past that least common denominator. Like this one, 5 and 10, it's really easy to just go to like 50, like just jump to 50, and then you're dealing with bigger numbers than you have to. So just take a second, look at each number, and just really try to think, like, what's the quickest path of least resistance? Like, you don't want to make things more difficult for yourself. So hopefully this helps you out with adding and subtracting with different denominators.